here to present the importance of iron and ferritin in our body. Iron is important mineral that is required for all the metabolism, and we consume 20 milligram of iron, and only 2 milligram is being absorbed. And ferritin is an intercellular protein that stores iron inside, and it prevents the radical formation. And iron ions are toxic in nature and it can form reactive oxygen species, so ferritin helps a lot. So it is important to understand the biomineralization process of ferritin so we can understand many diseases like Alzheimer's, Parkinson's, etc. So here I'm trying to show the biomineralization pathway of ferritins, where how the ferritin is being formed. So if you see here, the ferritin or the iron gets inside the epithelial cells, and the excess of the iron is being stored inside the ferritins. And then later, during the blood cell formation and death, the iron is recycled with the help of macrophages, and then the excess of iron is being stored in ferritin. So, apoferritin is the protein shell without iron. So, this is how it's being stored. And earlier they used conventional chemistry methods to understand ferritin, such as UV visible spectroscopy, gel electrophoresis, and other techniques to understand the biomineralization process. So if you see, this is the UV spectrum that shows the different ferritins and the absorption. And this is the gel electrophoresis method that is again showing different kinds. But there are some limitations with these techniques. So for example, we cannot quantify the H and L ferritins based on the UV methods because it's just based on the absorbance, and we can't resolve the structural and morphological aspects too. So we needed some better techniques. So people came up with electron microscopy techniques to understand ferritins. So the next part would be to understand ferritins using better solutions or electron microscopy techniques. So in earlier times they used conventional electron microscopy where they tried to use ferritins and image it, because with the electron microscopy we can solve the Abbe's diffraction limits, and the ferritin size is 20 nanometers, so it seemed to work better that way. And so if you see, this is the image that was taken earlier, which has the bright field and the dark field image of uh, ferritin, but it is the stained ferritin. And later they tried to use different other techniques. So if you see, this is the dark field image of ferritin again, and it shows how imaging was done earlier with the stained ferritin. And later people tried to find different other techniques to image ferritins, and so they tried to get better spatial resolution and analytical sensitivity. So they went with scanning electron microscope, as we see here in this slide. So this is the image of different kind of ferritins, that is hard ferritin and the spleen ferritins, and they try to show that the ferritins look different when it is hot and spleen. But these techniques had some limitations. So for example, we can see that they needed uh, the protein needed to be dried, and it can't be handled in a native state. So that's how the electron microscopy techniques work. And also it requires staining. So people try to look for other techniques where they try to go with in situ techniques. So in situ techniques, biological materials can be imaged in a native state without introducing any kind of artifacts. So this is one of the dynamic TEM image that is showing the ferritins in the in situ liquid state. But we had better techniques too for getting better resolution. So for example, use of graphene liquid cells. So here the ferritin is being encapsulated in a single layer of carbon, that is the graphene liquid cells. And if you see the images showing these better spatial resolution and better quality image, so we could see the atomic resolution of the particles and particles. So this can get to a better position or better shape, as we can see the biomineralization and demineralization process in H and L rich ferritins, and further we can compare healthy and dysfunctional ferritins. This could be helpful later when we want to understand certain diseases, as I mentioned earlier in this presentation. Thank you very much.